This meeting is being recorded.
So, ladies and gentlemen, I've shown you how to go from 5 1/4% to an equivalent reduced fraction. As I've shown you how to do 26.5% to reduce fraction, 2% as a reduced fraction, and 60% as a reduced fraction. All right, let's try this on our calculator now to speed things up. How would we convert 5 1/4% as into its equivalent reduced fractional form? Pretty simple to do. Let's bring up our machine, clear our screen, hit our fraction template. But now, ladies and gentlemen, in the numerator, I got to type in a mixed number, 5 1/4. So with my cursor sitting in the numerator, I have to bring my mixed number template up. Second fractional button brings the mixed number template up. Now we type 5 1/4.
Wait, what? Wait, clear a second.
Did we all get that there? I hit my fraction button first.
Okay, fraction.
Now with my cursor in the numerator, I have to bring up my mixed number template. So I would hit second fraction button to bring up the mixed number template in the fraction of in the numerator of the fraction that I first established. Is that making sense?
Yes. And
now we type in 5 and what? 1/4? Are you following me so far?
Second fraction. 5 1.
Five and 1/4.
You know, this is a silly question. Sorry to chime in. So when I want to move to the next spot, you know, like the 1, what I keep doing is hitting enter and clear.
Oh, okay. No, just follow me
because
here.
I can't figure out how to get there.
Okay, just go like this. Just start over. Hit your fraction button.
Okay, I'm sorry.
And now get your mixed number template. Second fraction key. Now you type in 5 1/4. So after you type the 5 in, you hit your right arrow key to move your cursor to the numerator. 1, and then hit your down arrow key to move it downstairs. Type in 4. You see that?
Yeah,
it's the arrow keypad. Hit your down arrow key. Now we go into the denominator. And we type in what? 100. And to bring your cursor back up to level, you hit your what? Right arrow key, correct?
Oh, I was hitting the wrong arrow. That's why. Okay.
Yeah, so yeah. This arrow keypad, we got an up arrow key, down, right, left.
Yeah, I was hitting those arrows down at the bottom by enter.
All right.
That's why I came up with the enter clear, because it would say error, and then I would go back and it would do it. Sure. Now I got it. Thank you so much. Sorry.
We got that figured out now. Okay, now hit enter, and boom, there's our fraction, ladies and gentlemen, 21/400. Do you agree? The calculator did it a little bit quicker, didn't it? Okay. So, you know, I would like you to, you know how to use this machine, because the calculator really is to be used quite a bit in this course. That's the beauty of Math 07 too. We can use this calculator. But you also see how I manually got that too. Do you agree? Just in case, you know, you're interested. And that's how we would manually negotiate that problem there. All righty. Okay, so any questions how we're converting a percent into a reduced fraction? Into a reduced fraction. All right, let's go back to our textbook here. And let's move on, see what else awaits us. I'll tell you what, so try this one, 66 2/3%. How would we turn that into a reduced fraction? 66 2/3%. And we can use our calculator here. So,
okay, so fraction, second fraction, 66.
66 and
that's so much easier.
Take it down to 100, correct? And that's all there is to it. Like, oh, now you just hit your enter button and boom, your machine's going to do a lot of work behind the scenes very quickly. You got your answer. Isn't that amazing? 2/3. That's a lot of work that just happened when you hit that enter button.
Yeah.
It's amazing what this machine can do. Okay. I mean, talk about saving time. All right. Okay. So that's how you turn a percent into a reduced fraction Now let's try to go backwards here. They want us to change these fractions back into fractions or mixed numbers, whatever the case might be, back into a percent. All right. Now, I have a question for you. Let's go back up here. How did I change these percents into fractions? I placed them over what, 100?
Yes.
In other words, I divided them by 100. Do you agree? Well, ladies and gentlemen, all we got to do is go backwards. What's the inverse operation of dividing by 100?
Multiplication.
Multiplying by 100. So to change a fraction to a percent, we just multiply it by 100. Okay, so let's recap what I just said here. To go from a percent to a fraction, ladies and gentlemen, what we do is we what? Divide by 100. Do you agree? So now to go from a fraction back to a what? Percent, we multiply by what?
100.
We multiply by 100. You see that little diagram here? To go from a percent to a fraction, we divide by 100. To go from a fraction back to a percent, we multiply by 100. That kind of summarizes it in a compact way. Do you agree? That's all there is to it. That diagram is very instructive because it really cuts through the chase. I mean, it shows us here. So like if I have the fraction 1/2 and I want to convert this 1/2 into a percent. Now think about it, ladies and gentlemen. If you eat 1/2 of a pizza, you consumed what percent of that pizza?
50.
50%. Isn't that true?
Mm-hmm.
Half of 100% is 50%. So we should suspect this to be equal to 50% when we get done. How do we do this though? We multiply 1/2 by what? By 100. And then we attach the what? The percent symbol. To manually show you how we do that, we would have 1/2 times 100% over 1. Now, what's 1/2 times 100% over 1? 1 times 100 is 100%. And that sits over 2 times 1, which is 2. Now, what's 100% divided by 2?
50.
You get your 50%. You see, that's manually how to show. I showed you how to change 1/2 to a percent. Multiply by 100%, and you got it. Let's show ourselves on the calculator how we would do this. Pretty simple. All we do is we take 1/2, the fraction 1/2, and we multiply it by
100.
100. That's all there is to this. Hit enter. Boom, you get your answer, which is what? 50? 50%. That's it. That's what you're going to do with every one of these problems here. Every one, 53 through 68. To change these fractions to a percent, you multiply them all by 100%. What's another one you want to see in here? Take your pick. Go ahead, pick one.
67.
67, okay, 1.5. Hey, think about this from a realistic standpoint. If you've consumed 1.5 pizzas, ladies and gentlemen, you've consumed one whole pizza, which is what, 100% of the pizza. Do you agree?
Mhm.
Plus you consumed 1/2 of another whole pizza, which means you ate what, 50% of that pizza. How much pizza did you eat totally, percentage-wise? 100 plus 50 is what?
150.
150% of the pizza you ate. Does that make sense? One whole, 100%, half another one, 50%, 150% pizza.
Mm-hmm.
Okay, let's try this on our calculator. Just convert 1.5 into a percent. Simple thing to do. Bring up your mixed number template. Hit your second button and your fraction button. Type in 1 in 1/2. And just multiply this by 100. And that's your answer, 150%. Don't forget to attach the percent symbol though, very important, 150%. Does that seem right that 1.5 would be 150%? 1.5 of anything is 150% of something, okay? So if you ate one whole pizza and 1/2 of another whole pizza, you consumed 150% of pizza. All right, let's try another one here. How about 3 1/4? Now, if you consume 3 whole pizzas and 1/4 or 1/4 of another one, you consume 300% plus 1/4 of 100% more pizza. Do you agree? And 1/4 of 100% is known as 25%. So this better convert into 325% of the pizza you consume. 3 whole pizzas is 300%. 1/4 of another whole pizza is 25%, 325%. So how would we convert that into a percent? So we take 3 1/4. Bring your mixed number template up here, 3 1/4. And then we're just going to multiply this by what?
100.
By 100. It's that simple, and you got 325%. If you oh, you know what? I didn't even do a screen share there, ladies and gentlemen. I apologize. I'm sorry. I wasn't screen sharing. Yeah, 3 1/4 times 100 gives you 325%. That's what 3 1/4 would be as a percent there. Okay. Manually, how would you do that? How would you convert 3 1/4 into a percent? Well, you multiply it by 100%. And so it's going to be 3 1/4 times 100% over 1. Change the mixed number into an improper fraction. 3 times 4 is 12. And 12 plus 1 is 13. So we have 13/4 times 100%. When you multiply across, you're going to have 1300% divided by 4. And 4 divides into 1300, 325 times. And that would give you 325%. Okay. So to recap, to go from a percent to a fraction, we divide by 100. Drop the percent symbol. To go from a fraction back to a percent, we multiply by 100 and attach the percent symbol. All right. So, ladies and gentlemen, that's that basically is in a nutshell. That's section 6.1. Everybody see that there? All right. So for classwork 1, I'm going to give you a couple problems to do out of this section here. Today is January 25th. So we're getting through the month of January here. Okay. So I'll give you a couple problems to do for classwork number 1. Here they are. Problem number 1, I want you to convert to a percent this decimal. Convert that to a percent. Number 2, I want you to convert to a decimal. Convert this to a decimal. Okay, convert that to a decimal. Problem number 3. I want you to convert to a reduced fraction. If we have 65%, convert that to a reduced fraction. Problem number 4, convert to a percent. I want you to take this fraction and convert it to a percent. Let's say here. Okay, how about 1 2/5? Convert that to a percent. All right, so we'll call that classwork number 1. Okay.
Number 4, what is that number again? It's 1 and 2. Oh, there we go. Thank you. Sorry, my screen.
Yeah, it's
messed
1
up.
and 2/5. Yep. All right, let's take a look at this here. What would 0.003 or 3 thousandths be as a percent? From a decimal to a percent, to the right we went. 2 places to the right. So it'd be 0.3%. Make sure you attach the percent symbol. 14.3% as a decimal. From a percent to a decimal, to the left we roll. 2 places to the left. 1, 2. 0.143, drop the percent symbol. 65% as a reduced fraction. We put 65 over what, 100?
Mhm.
And then we just reduce this fraction down. 5 divides into both numerator and denominator, takes it down to 13 over what, 20?
20, yeah.
13 20ths. Finally, 1 and 2/5 percent. You can just multiply this by what? To change 1
100.
2/5 percent, multiply it by 100%.
Mm-hmm.
And that should take it to what?
140.
140%.
Yes.
And it makes sense because 1 whole means 100%. So you know you at least have 100%. 2/5 is the extra 40%. Okay, there you go. All right, so we'll call that classwork number 1. How did we do on that? Get that correct?
Yes.
All righty. Let's move on, Liz, on the next section. 6.2 is awaiting us. All right, so yeah, that'll be classwork number 1. All right, section 6.2. Let's see what it's all about. Well, what it says is basic percent problems. Okay, so we're going to learn how to solve basic percent problems. And on the first page of section 6.2, there's an important shaded box, ladies and gentlemen. And in this shaded box, it kind of gives us an idea as to how to translate words into appropriate mathematical operators or symbols. When you see the word is in a word problem, that suggests that we would replace it with the equal sign. Is means equals. Of means multiply. When you see the word of, it means multiply. If you see the phrase a number, we replace it with a variable, an unknown. Normally they use the variable and. You can use X or any other variable you want to use. If you see the phrase what number, that means unknown. Replace it with a variable. If you see the phrase what percent, that means unknown. Replace it with a variable. Okay. So what we're going to do here is we're going to learn how, ladies and gentlemen, to translate words, a percent word problem into an equation, and then we're going to solve the equation. So I'm just going to drop on down to page, the exercise set in section 6.2, and we'll start doing some of these problems here, okay? All right, problem number 1, it says what number is 25% of 32? Okay. So it says what number is 25% of 32? And what we're going to do here is we're going to convert this question into an equation. Now, when you see the phrase what number, what does that mean again? From that shaded box that I just showed you, it means unknown. Do you agree?
Yes. So we end.
So we could use a variable n to represent what number because it's unknown. Or you could use some other letter like X or Y. It doesn't matter what you call your variable. I'm going to use n. Is means what symbol? The word is. Do you remember?
Equal sign.
Equal. Now, 25% of 32. Of means to do what?
Of means to multiply.
Multiply. So to take 25% of 32, we change the percent first into a decimal. How do you change a percent to a decimal? To the left we roll,
Yes.
2 places to the left of the decimal point. So 25% is 0.25 or 25 hundredths. Of means to multiply. So we're going to take 0.25 now and multiply it by 32. And ladies and gentlemen, you can do this on your calculator. What is 0.25 times 32? Go ahead and dial it up.
8.
It gives you 8. And we're done. Therefore, you might want to check your answer for reasonableness. Does this seem about right to say that 8 is 25% of 32? Does that seem about right? Well, as I'm 100% of 32 would be what? 100% of 32 would equal 32, correct? 50% of 32 would be what? Half of 32, which is what, 16?
Mhm.
What's half of 50%? What's half of 50%?
25.
25%. So it seems like 25% of what's half of 32, excuse me. Yeah, 25, it seems like 25% of 32 then would be half of 16. What's half of 16?
8.
Aha, makes sense, doesn't it? Doesn't seem about right?
Mhm.
So yeah, it seems like your answer should be 8 for that problem. So 25% of 32 turns out to be 8. Because 25% is 1/4 of something, isn't it? 1/4 of something. If you eat 25% of a pizza, ladies, I mean, you only consumed 1/4 of the pizza. 1/4 of 32 is 8, isn't it? All righty.
Mhm.
Let's try another one here. Okay, number 2, what number is 10% of 80? So what number is 10% of 80? So we'll try to convert this into an equation. What number means unknown, is means equals. 10% of 80, we change the percent to a decimal by shifting the decimal point 2 places to the left. So that's 0.10. Of means multiply. So we're going to multiply 0.10 times 80. And what does that give you? What's 10% of 80?
8 again.
8 again, isn't it? Okay, 8 again. All right. Okay, that would be your answer. All right. The question is how we're converting our words into equations here. All right, now let's jump down to one like number 9. It says, what percent of 24 is 12? What percent of 12 is, wait, what percent of 24, excuse me, is 12? What percent of 24 is 12? I replace what percent with what? An unknown, a variable? What percent of means what operator? Of means to multiply.
Multiply.
Of means to multiply. Times 24. Is means what symbol?
Equals.
Equals 12. Everybody see how he set this equation up here? What percent means variable, unknown. Of means multiply, 24, 24. Is means equals, 12, 12. See that? Now, n times 24 is more appropriately called 24n, or 24 times n. Ladies and gentlemen, we got to actually go back to last week. Do you remember how we solved equations like this when we were solving proportions? Remember we had to divide, use our division property?
Yes.
What do I divide both sides by now?
24.
Yep, divide both sides by 24. So we're tapping into what we learned last week. And therefore, this implies that what? 24n divided by 24 reduces down to n. Then what's 12 over 24? How does 12 24ths reduce?
Be 1/2.
1/2, correct?
Mhm.
Now, what would 1/2 be as a percent? Because we're really missing the percent in this word problem. Our answer needs to be a percent. So to change 1/2 to a percent, we multiply it by 100%, do we not? And would we not get what, 50%?
Yes.
There you go. Does that seem right, ladies and gentlemen, that 50% of 24 is 12? 50% is half, do you agree? Half of 24 is 12? Does that seem right?
Mhm.
Seems right, doesn't it? Your answer is 50% there. Any questions how we did that problem? So there we were missing the percent. Okay. Now we could try another one like that. Number 13, it says what percent of 36 is 9? What percent of 36 is 9? This is problem number 13 in section 6.2. What percent of 36 is 9? Well, it's translated into an equation. What percent means unknown, n. Of means times. 36 is means equals 9. We have our equation. Now this is better known as 36n is equal to 9. So what do I divide both sides of this equation by to solve for n?
36.
So we divide both sides by 36. The left side simplifies or reduces down to 1n or n. And the right side, 936, reduces down to 1/4. But notice we're missing our percent again. So we want to turn 1/4 into a percent. So easily done by multiplying it by 100%. That gives you 100% divided by 4, which gives you 20 what? 5%?
Yes.
And we're done with that problem. Does it seem right that 25% of 36 is about 9? Well, 50% of 36 is half of 36, which is 18. Then half of 50% is 25%, and half of 18 is 9. That seems about right, correct?
Mhm.
Questions how we're converting words or questions into equations and then solving the equation to answer the word problem. All right, now we're going to look at one like number 18. It says 16 is 20% of what number? Number 18. It says 16 is 20% of what number? So let's try to convert this into an equation in order to answer the word problem. 16 is 20% of what number? So here we go. 16 is means what symbol?
Equals.
Equals 20% of what number? By the way, what number means unknown? It's missing, correct? That means like the variable n. 20% of, how do you take 20% of n? Change a percent to a decimal, shifting decimal point 2 places to the left, which is 0.20. And of means to do what? Multiply. Now we have our equation. 16 is equal to 0.20 times n. Questions how I converted this question into an equation. Now, how do we solve the equation? What do I got to divide both sides by?
0.20.
0.20. This reduces down to 1n or n. Get on your calculator. What's 16 divided by 0.20?
80.
Answer is 80, and we got our answer. Okay. So as it turns out, 16 is 20% of what? 80, correct? 16 is 20% of 80. Does that seem about right? That 16 is 20. 20% of 80?
Mhm.
Well, 50% of 80 is half of 80, which is 40. Half of 50% is 25%, and half of 40 is 20. 20% is less than 25%, so 16 would be less than 20. That seems about right, correct? Line of reasoning there. Okay, any questions, ladies, on how we're converting words into equations and then solving equations to answer the word problem? Okay. All right. So that brings me to classwork number 2, ladies and gentlemen. I'll give you a couple problems out of this section that I want you to work with. So classwork number 2. Again, it is January 25th. All right. For question number 1, I want you to answer this question. 10% of what number? 10% of what number is 22? Set up an equation, solve the equation, answer the question. Problem number 2. 28% of 49 is what number? Answer that one. And then this one, 65 is what percent of 130? There you go, ladies and gentlemen. 3 problems. We'll call that classwork number 2. See if you can do those. Set them up as equations and then solve the equation to answer the problem. If you're searching for a percent, make sure to attach the percent at the end to your number, if or percent is what they want us to find. Okay, go ahead and try to tackle. Okay, there's the solutions for each of these problems. Are any of these numbers checking out? Anybody getting these?
Yeah.
Okay. So in that section, what we learned how to do is convert a percent word problem into an equation. Then we solve the equation to answer the percent word problem. All right. Let me know when we're ready to move on. Okay. We good on these, ladies and gentlemen?
Yeah. Yeah.
All right, so we just have two more sections, 6.3 now. We'll go into that section and see what that holds for us. It's entitled General Applications of Percents. General Applications of Percents. So that's what we will try to do, is apply percents to general word problems. Okay, so this is jump down. The only way to learn how to do these is by seeing a bunch of them done. So I'm going to wade through several of these here. So these problems begin in exercise set 6.3, which is on page 289 in your textbook. This is where we will begin to tackle these here. Now it says solve each of the following problems by first restating it as one of the three basic percent problems from the previous section. In each case, be sure to show the equation. All right, we'll try number one here to ease us into this. It says on a 120 question test, a student answered 84 questions correctly. What percent of the problems did the student answer correctly? Okay, so ladies and gentlemen, we're going to try to set this up as a an equation. So let's see here. What percent of the problems did the student work correctly? So the question they're asking at the end there is suggesting what percent of how many problems were there on this test?
120
So what percent of the 120 problems,
is
okay,
84.
were what? Correct. Think of the question as being phrased that way. So what percent of 120 problems were correct? All right. Now let's try to convert this into an equation. What percent means we don't know. That's an unknown. That'll be n. Of means times 120. Were, ladies and gentlemen, were means the same thing as is, equal sign. And how many were correct? Were there not 84 correct?
Mm-hmm.
You got your equation. See how we transform those words into an equation? What percent of the problems on the test were answered correctly? In other words, what percent of the 120 problems on the test were answered correctly? And the number that were answered correctly, they indicated was 84. So now we just have to solve this equation for n. And this is better known as 120n over equals 84. What do we divide both sides by?
120.
Okay. So therefore, now notice we're missing a percent. That's what they're asking us to find. So we want to convert this fraction into a percent. And it's easy to do. Multiply it by 100%. And you can even do that on your calculator. Go ahead and do that. What's 84 over 120 times 100%? Tell me what that would be as a percent.
Seven? No, that's not right.
Well, let's see.
That's not correct.
Let me know when you
I
get
mean,
it.
70%.
70%.
Yes.
And there you go, ladies and gentlemen. So the person answered 70% of the questions correctly, correct? 70% of the problems were correct. That means they answered what percent incorrectly?
30%.
30%, 100% minus 70% or 30%. Okay, any questions how we translated that word problem into an equation and then solved the equation to answer the problem? Let me just try to do a couple more of these here. More of these you do, the more experience you're going to get. Number 2, an engineering student answered 81 questions correctly on a 90-question trigonometry test. What percent of the questions did she answer correctly? What percent were answered incorrectly? This problem is very, very similar to the last problem. So I want you to set up an equation. Now, everybody set up an equation for number 2. And we're going to solve that equation to answer this question. On a 90-question trigonometry test, 81 questions were answered correctly. What percent does that represent? See if we can set up an equation. So think of the question this way. What percent of 90 questions were answered correctly? What percent means are percents missing? Of means multiply times 90. Were means equals. And the number that were answered correctly was 81. There you go. There's your equation. I'll just solve for n. Divide both sides by 90. And so this implies that n is going to be equal to 81 over 90. Then you can turn this into a percent and by multiplying it by 100%. And what do we get?
90.
90%. So 90% of the questions were answered what? Correctly?
Oh,
And what percent are incorrect then?
10%.
100% minus 90% is 10% incorrect. Make sense how we did that problem? Any questions? How we translated that into an equation to answer the problem. All right, let's go down now. Look at some other ones here. Number 3, a solution of alcohol and water is 80% alcohol. The solution is found to contain 32 milliliters of alcohol. How many milliliters total of both alcohol and water are in the solution? This is a little bit more advanced of a question. How are we going to negotiate this one, ladies? I'm number 3. Well, let's say a solution of alcohol and water is 80% alcohol. Okay. The solution is found to contain 32 milliliters of alcohol. How many milliliters of total, both alcohol and water, are in the solution? Okay. Well, 80% of the solution is what? Alcohol, correct? Alcohol. 80% of the solution is alcohol.
So 80%. Wait.
Now, 80% of the solution, but do we know how much solution there is total? 80% of, I should say, of the total solution. 80% of the total solution is alcohol. We don't know how much total solution there is. Do you agree?
Right.
That's a variable. So 80% of, we'll call it N, means equals. And how much is alcohol, though? They did give us the number of milliliters that is alcohol.
32.
32 milliliters is alcohol. John, we have an equation starting to evolve here. So 80% of our total solution is equal to 32 milliliters of alcohol. How do you take a percent of a number? Change a percent to a decimal, move decimal point 2 places to the left, drop the percent symbol. Of means multiply. And there's your equation. Now we can solve for n, which will give us the total amount of solution that we had in milliliters. To answer that question, we divide both sides of our equation by 0.80.
That's 40%.
Now, they're not asking us for a percent.
Mm.
They're asking us for the total amount of solution that exists, which is going to be milliliters, not a percent.
Okay.
So solving for n, these reduce down to 1, and we're left with n is equal to, now it's 32 divided by 0.8. You could try that on your calculator.
32. Not 32, it would be 40.
What does that give you?
40.
40.
40 milliliters.
So
Oh, then
40
there's more.
milliliters
Oh,
is the total what?
30.
Volume, correct? Total volume of the solution. And there you go, ladies and gentlemen. So we totally had what? 40 milliliters of a total solution. And of the 40 milliliters, 32 milliliters is pure alcohol. And therefore 8 milliliters would have to be what? Pure water, correct?
Right.
Is that correct? Yeah, 8 milliliters would be pure water, 32 milliliters is pure alcohol, so that we have a total volume in our solution as being 40 milliliters here. Any questions how we did that problem there? This one's an interesting one. I'll probably save number 4 for a minute. Let's see, maybe a classwork there. We'll come back and do that. Okay, let's go down here. There's number 7. A farmer owns 28 acres of land. Of the 28 acres, only 65% can be farmed. How many acres are available for farming? How many are not available for farming? Okay, let's try number 7. So, of the 28 acres, 65% can actually be, of the 28 acres owned, only 65% can be farmed. How many acres are available for farming? Well, the number of acres available for farming is going to be 65% of what?
28.
28 acres, right?
Oh.
So that's what we really need to find out here. 65% of 28 acres is land that can be farmed. Apparently, some of this land is no good where you cannot farm it. Maybe it's like a swamp or something, or a low area, correct? So how many of the 28 acres can be farmed? Well, 65% of the 28 acres. How do you take 65% of 28? Change the percent to a decimal, shift decimal 20.2 places to the left. Of means multiply. So now you multiply it by 28. And you tell me how many of the 28 acres can be farmed? What's 6.65 times 28?
18.2.
All right, so 18.2 acres can be what? Farmed. How many acres cannot be farmed? How would you find that out now?
22.8.
Well, you would take the total number of acreage, which is what, 28 acres, and subtract off what the number of acres that can be farmed, correct?
72.8. Yeah.
So 28 acres minus 18.2 acres that can be farmed leaves us with how many acres that cannot be farmed? What's 28 minus 18.2?
Be 9.8.
Yep, so 9.8 acres cannot be farmed. And I think we've answered that problem there. Okay. What if 100% of the land could be farmed? How many acres would that be? If 100% of the land could be farmed, that would be how many acres that could be farmed? What's 100% of 28?
28.
Yeah, all 28 acres, correct? What if
Right.
only 50% of the 28 acres could be farmed? How many acres would that be?
14.
14. Yeah, half of the land could only be farmed because 50% of something is half of something. Okay. All right. Okay, so that was an interesting problem there. Let's see here. All right, let's try number 11. Suppose 60% of the graduating class in a certain high school goes on to college. If 240 students from this graduating class are going on to college, how many students are there in the graduating class? How would we set some sort of an equation up here, ladies and gentlemen? 60% of the graduating class are going to college. Do we know how many people there are in the graduating class? No, in fact, they're asking us what to find that. Do you agree? So let's start to write this down on our paper. 60% of graduating class goes to college. Okay, so look what I've written down for number 11 on my paper. 60% of graduating class goes to college. Let's try to refine this into an equation. 60% of, do we know how many people are in our graduating class? Do we know that? Were there 240 students in our graduating class?
This is if, yes.
Oh, there were only 240 students in our graduating class?
It says if 240 students from the graduating class are going to college.
Oh, so does that mean that there were 240 students in the graduating class?
No,
No. That indicates just how many are going to college, correct?
correct.
In fact, we don't know how many people there were in the graduating class. That's what they're asking us to find. And so, ladies and gentlemen, the number of people in the graduating class should be denoted by what? A variable. Do you agree? We don't know it. It's unknown. Call it N. Okay, so 60% of the total number of people in the graduating class, which we call N, we don't know what that is, was equal to how many people that went to college?
240.
240. Look at this equation now. It's starting to refine itself. You see that? Now we're really poised to set up the equation. So how do you take 60% of N? Change the percent to a decimal, 2 places to the left decimal point, which is 0.60. Of means multiply. So then you multiply this by N and you set this equal to 240. We now need to solve for N, which would be the total number of students in the graduating class. How to solve for N? What do we do? Divide both sides by 0.6. Yeah, by 0.6 or 0.60, doesn't matter which one.
Okay.
Get on your calculator and dial it up. What is 240 divided by 0.6 or 0.60?
400.
Gives you 100?
400.
400. So 400 represents what? Is that the number of people that went to college?
No.
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 In the
What was
graduating
400?
class.
Yeah, 400
graduating
students.
class?
Yeah, there were 400 students in the what?
Graduating class.
In the graduating class. And of the 400 students, 240 of them decided to go to college. That leaves how many that did not go to college? That would be 400 minus 240, do you agree? Which would leave you with how many that did not go to college? That would be
160.
160 did not go to college. There you go. All righty. So we're negotiating some of these word problems here, Liza. Everyone's a little bit different, so you have to do a lot of these to get good at these, okay? And I'm trying to demonstrate as many as possible here. All right. Okay, so I'm going to give you classwork. We're up to classwork number, what, 3 now, aren't we?
Yes.
Okay. So it's time for classwork number 3. I would like you to do, let's see. I would like you to do problems 14 and 16 for classwork number 3, number 14 and 16 in your textbook in section 6.3. 14 and 16. Number 14, in a certain school, 75% of the students in the first year chemistry have had algebra. If there are 300 students in first year chemistry, how many of them had algebra? Number 16, if 45 people enrolled in a psychology course, but only 35 completed it, what percent of the students completed the course? All right, try those problems there. All right, number 14 says, in a certain school, 75% of the students in the first year chemistry have had algebra. If there are 300 students in the first year chemistry, how many of them had algebra? Did anybody get that correct? Feel confident? What'd you get?
I want to say 225.
Okay, that sounds real good. Okay, so therefore 75% of 300 students had algebra. So you take 75% of 300, which means you multiply 0.75 times 300. You are correct. 225 students had algebra. The second one says, what percent of the 45 people enrolled in psychology actually completed psychology? So what percent of 45 students enrolled in psychology actually completed psychology? This would be the equation you set up. Then you solve for the percent. Make sure your final answer is rounded off to the nearest tenths, one decimal point place, and you attach the percent symbol. Did we get that correct there?
Mm-hmm.
All right, nice job. So in that section, we learned how to convert word problems into percent word problems into equations. And then we ultimately solve the equation to answer the word problem and answer what it is they were asking us to find. Okay. All right, there's only one last section, ladies and gentlemen, 6.4. Let's see what that section holds. So we've done 3 classwork so far. So section 6.4 is entitled Sales Tax and Commission. You know, this was weird. I didn't know that. You see these suckers here? These suckers actually have an insect embedded in them. Like this blue one has a scorpion in it. Would you buy one of those suckers, ladies and gentlemen?
No.
Oh, I don't know what the fascination is with those. You know what I'm saying? I could not handle one that had a spider embedded in it. No way. No way.
I would
That's
just
me.
look at it, but I wouldn't buy it.
Yeah, I wouldn't be sucking on those. That's just me. But you know, some people would. They'd say, well, it's just a dead bug, no big deal. All right, sales tax and commission. Do we pay sales tax in this state?
Yes.
Yes.
Yes, we do. For every non-food item we purchase, does anybody know what the sales tax rate is in Michigan?
6%.
6%. So that means for every dollar of a non-food item we purchase, we pay Uncle Sam, what, 6 cents? Do you agree? 6 cents on a dollar. What's commission? What's commission?
It's like an earned percentage of the sale.
Yeah, give me an example of a person that has a job that would earn a commission. Can you give me an example?
Car salesman,
Car salesperson. How
cell
about
phone sales.
yeah, salesperson in general? You know, like if you walk into like Value City Furniture, you know, there's probably going to be some people that flock to you very quickly. Do you agree? Can I help you? Can I help you? Can I help you? You know what I mean? Because they know if they can sell something to you, they're going to make a commission, correct?
Mm-hmm.
All right. And so that's what commission involves, is somebody that basically works in retail sales, or, you know, works in the auto industry and is selling automobiles. They earn a commission in addition to maybe like a flat annual salary that they might make too. You know, commissions are kind of analogous to like tips too. Do you agree that waiters or waitresses would make? Do you agree? Tips are kind of like commission, aren't they? In a way, the more tables you wait, correct? It seems to me like you'd be a better chance of earning more tips, correct? More commission. All right, let's go right down to the problems, begin to immerse ourselves in these problems in section 6.4 here. All right, problem number 1, it says, suppose the sales tax rate in Mississippi is 7% of the purchase price. If a new food processor sells for $750, how much is the sales tax that will be owed at the register? Well, ladies and gentlemen, we know that we can set up an equation here for section 6.4 that says the amount of sales tax that you're going to have to pay is equal to the sales tax rate times the what? The amount of sales, correct? Now down there in Mississippi, the sales tax rate is 7%. And the cost of the food blender, I believe, is $750. They want to know how much sales tax we will have to pay. Well, it's pretty simple. You just take 7% of $750, correct? That'll give you the amount of sales tax that you have to pay. So how do you take 7% of 750? Well, pretty simple. You just have to convert the percent to a decimal by shifting the decimal point 2 places to the left. 1, 2, so we gotta add a 0 and then dropping the percent symbol. So this will be 0.07. Of means multiply. And so we're gonna multiply 0.07 times $750. Get on your calculator and dial it up, ladies and gentlemen. Tell me how much sales tax we're gonna have to pay for the $750 food processor in Mississippi. What is 0.07 times 750?
52.5.
All right, so we're gonna owe $52.50. Boy, that's a lot of tax. Do you agree? I mean, that's a lot of money, but that's the way it is, you know? $52.50 of tax. Questions how we did that problem? All right, let's drop on down. Okay, let's try this one, number 6 now. It says the sales tax on a new microwave oven is $30. That's the amount of sales tax we pay. If the sales tax rate is 5%, what was the original purchase price of the microwave oven? And then they want you to indicate what the total price would be that you would pay at the register. Okay, so ladies and gentlemen, here we go. We know that sales tax is equal to what? Is equal to the tax rate, correct? The sales tax rate times the what? Times the price of the item, correct? What do we know? Now that $30 represents what? Is that sales tax? Or is that the tax rate? Or is that the original price of the microwave oven at $30?
The sales tax of the new.
That's the sales tax. So that $30 would go in place of sales tax on the left side of our equation here. That is the sales tax we were charged. You see that? Do we know the sales tax rate for this microwave oven?
5%.
5%. So the sales tax rate is 5% of what was the price of the microwave oven? Did they tell us that?
No, so it'll be in.
No, they want us to find that. So we call it a variable. That's right. It's an unknown. So we call it n. We got to solve for the price of this microwave oven. We got to solve this equation for n. So our equation would be 30 is equal to 0.05 times n. Don't forget to change the percent to a decimal. Now we solve for n by dividing both sides by what? .05. Get on your calculator and dial it up, ladies and gentlemen. What's 30 divided by 500ths? Tell me the price of that microwave.
$600.
$600 was the price of the microwave. This is the price of the microwave. Now they want the total price. And how would we find the total price? The total price would be found by taking the price of the microwave, which is $600, and adding to that. What do we add to that? We add
30.
the $30 of sales tax. Heck, we're going to be paying $630 at the register. Do you agree? That includes tax. And we're done with that problem. always check your answer for reasonableness when you get done doing a word problem. If it don't seem reasonable, then there probably was a mistake somewhere. In other words, if we computed this price to be like $3,030, do you agree? There's probably a mistake somewhere. I mean, I'm not laying out no $3,030 for a microwave oven, are you, ladies and gentlemen? All right, all right, okay. Always check for reasonableness. That seems about right. $630, even that's a little high for a microwave. I don't know. It depends, you know.
I'm not paying it for it.
Yeah, I mean, you know, for a microwave oven, I mean, you know, I know I could do a little better than that. Okay, but yeah, it depends. Maybe that was a very, you know, elaborate microwave oven or something. You know, the one that you use permanently for quite a while or something. All right, let's go on down here. Now, let's go down to like a commission problem, number 10 here. It says a tire salesperson has a 12% commission rate. If he sells a set of radial tires for $400, what is his commission that he will earn? Ladies and gentlemen, for every dollar he sells, he will earn 12% of that. Do you agree? What's 12% of a dollar? What's 12% of 100 cents? That's 12 per 100 cents. That's 12 cents per 100 cents. Isn't that 12% per 100? He earns 12 cents on every dollar he sells. How much commission would this person earn? Well, we know that commission is equal to what? The commission rate times the what? The amount of sales, correct? So we have another equation that involves commission here. Commission is equal to rate times sales. And what is the commission rate? 12%? We don't know the commission he earns, so we'll call that N. The commission rate is 12%, as a decimal is 0.12. And the tires he sells was worth $400. There you go. Just get on your calculator, multiply 0.12 times 400, and you will figure out how much commission you will earn by having sold you those tires. So he's going to earn what kind of commission?
Be 48.
Yeah, he'll earn $48 of commission. Now that doesn't seem like a lot, ladies and gentlemen, but stop and think. If you know, I mean, if you sell 10 sets of tires for $400 for the entire day, you make an extra what? $480 for the day. Do you agree? That's not a bad deal. That's almost like half $1,000 there. Okay, just in commission alone. Pretty good deal there. All right. All right, now number 14 twists things around a little bit. It says a realtor, person who sells homes, makes a commission of $3,600 on $90,000 house he sells. What is his commission rate? So ladies, we're going to use the same equation, but what goes where? Do they give us the commission that was earned?
14.
The commission earned was $3,600.
Yes.
The
Yeah.
sales was what?
90,000.
$90,000, and they want the commission rate. Now, when they're talking about finding the commission rate, that means what? Our percentage is missing, isn't it? Our commission percent. You got to solve for the commission rate, N, which is a percent.
Okay.
So how do we solve this equation for N? We divide both sides by
90,000. 06.
90,000.
Yeah.
All right. And then you'll convert that into a what? Percent. Do you agree? Because it should be a percent. So you'll multiply that by 100%. Tell me what the commission rate is as a percent. Go ahead and dial that up. So what's the commission rate as a percent for this this realtor, real estate agent?
%4.
4%. Anybody else get 4%? So we double check. Anybody else get 4%? This would be a 4%. We say commission, what?
Rate. Was it rate?
Rate, commission rate. That's the 4% commission rate. So this person earns 4 cents on a dollar. For every dollar they sell, 4 cents. Yeah, doesn't seem like a lot of money, but when you sell a $90,000 house, do you agree that's not a bad commission for the day? Do you agree? $3,600. I could definitely handle that. Do we see how we're doing these problems here, ladies and gentlemen, involving either sales tax or commission here? All right. Try one last problem for classwork number 4. Number 9, if a real estate agent has a commission rate of 3%, if a piece of property sells for $94,000, what is her commission that she earns? We'll call that classwork 4. That's the last one today, number 9. Anybody get the amount of commission? So the commission rate was 3%. They sell $94,000 home. How much commission did she earn?
2820.
I'm getting like $2,800 and what, $20?
Yes.
Okay, that'd be the commission that was earned for the day there, if that's all she sells in one day. You know. So there you have it, ladies and gentlemen. We covered quite a bit of ground today. We worked basically with percents and percent word problems. That constituted section 6.1 through 6.1, 6.2, 6.3, 6.4. And I believe we're right up to date where we need to be. Do you agree? According to our schedule. Today's
Yep.
the 25th day. Yes, we got through 6.4. All right. Now, quiz 2 was due by what? Midnight last night. If you did not turn that in, please get that in ASAP, ladies and gentlemen. Quiz 1, about halfway through grading quiz 1, and I'll get those graded and recorded on Canvas there. All right, and I will update your homework in your textbook, so please try to stay up with the homework assignments. And any other questions before I let you go? Okay, you have a great day then, and hopefully I'll catch you on the tail end of this week on Thursday, okay?
Alrighty.
All righty, take care.
Thank you too.